What's up everyone? In this video we're going to be talking about finding the volume of composite figures. So here's a refresher. We've dealt with composite or compound figures in 2 dimensions, and that was just composing 2 or more geometric figures together. And in 3D that's the same exact thing. So what we're doing instead is instead of combining 2D figures, we're going to just combine a bunch of 3D figures to make a composite or compound 3D shape. So these shapes, remember, are usually split up into familiar shapes, and now we're going to be calculating the volume of that total figure. So here you can see an example of a 2D composite figure versus a similar looking 3D composite figure, and all we're doing is now we're taking these 2D figures and kind of adding an extra dimension to them, and then they become composite 3D shapes. So on our reference sheet, when we take a visit over there, you'll see that all of our volume formulas that we need are in this bottom left corner. So that's going to be really helpful for us. And notice that, remember, volume is capital B times H, where B was the area of your base shape. So remember, we can have like circular bases or triangular bases, and it really helps too because up here on this side we have all of those area formulas. So if you need the area formula for a triangle, let's say, you can take it, plug it into capital B, and then you have your volume formula. So let's get right into the first skill. The first skill is just finding the volume of these composite 3D shapes. So here we have a grain silo can be modeled by a right cylinder topped with a hemisphere. So we have 2 shapes here. And it wants us to find out how many cubic meters of grains are going to fit in the silo if it has a height of 79 meters and a radius of 7 meters. And we're going to round our answer to the nearest tenth if necessary. So with these questions, the whole idea is if you want the total volume of this 3D figure, you need to find the volume of however many figures are involved, and then you just add them up together. So in this little formula that I gave you guys here, there might not always be 3 shapes. There could be way more than 3 shapes. There could be 20 shapes. Or maybe there's just 2 shapes, like in this example. So we always want to identify what our shapes are. So the first shape we have is a cylinder. And the second shape that we have is a hemisphere. Now, it also is going to be really helpful if we go back to the diagram and look at the dimensions, because here we have that the height of the entire silo is 79 meters. But what you want to notice is that, hey, that's not the height. The height of the cylinder is going to be a little bit smaller than that. So what I recommend doing is sketching out your shapes. So here's our cylinder. We know that the radius is 7, but to figure out our height, we have to kind of see, hey, the whole height is 79, and we know that the radius of this circular part here is going to be 7. So maybe if we fill that in right here, that radius, right? If we do 79 minus 7, the height of our cylinder is actually going to be 72 meters. So again, what we did was we filled in this radius value, because again, remember, this is a hemisphere. So what that means is that this value going from the top of the cylinder all the way up to that circular part of the silo, that's going to be the radius. And we know that the radius is 7. So if we do 79 minus 7, that's going to give us just this value right here, which is 72. So you want to be really careful what the measurements are actually representing, just so that you don't mess up. So now that we have our cylinder kind of sketched out, let's take a visit to our reference sheet. So on our reference sheet, if we take a look here, we have the formula for a cylinder. So the volume is pi r squared times h. So we write that out, pi r squared times h. We already know that our radius is 7, so we're going to square that, times the height of our cylinder, which is 72. And since we're rounding it to the nearest tenth, that means that we're going to put pi into our calculator as well. So when we go to our calculator, you can literally type all of this in. So we have pi times our radius, which was 7, and we're going to square that. And then the height of our cylinder was 72. And when we put all of that in, we get a really big number. So 11,083.5. And our units are going to be meters cubed. Now, this is us rounding to the nearest tenth, but if it wanted us to leave it in terms of pi, that means that we would put all of this into our calculator, and then whatever number we'd get, we'd just put pi right in front of it. So that's our first shape. Now we need to go ahead and find the volume of our second shape. So let's actually go ahead and make this a different color just so that we can see what's happening here. So our second shape is going to be this hemisphere right here. And I'm going to go ahead and sketch it out. So your sketches don't have to be perfect. They're really just to help you see what's going on. And the only thing that we really know about this is that the radius is 7. So if we go to our reference sheet again, we aren't given the volume of a hemisphere, but we are given the volume formula for a sphere. And remember, a hemisphere is just half of that. So the volume of a sphere is 4 over 3 times pi r cubed. So V equals 4 over 3 times pi r cubed. And remember, this is for the entire sphere. So what we're going to have to do at the end is we're going to have to just divide it by 2. So let's go ahead and substitute. V equals 4 over 3 pi. Our radius is 7, and we're cubing that. So now let's go ahead into our calculator. So you want to be really careful when you're typing all of this in. It really, really helps if you can type it in as perfectly as possible. So we have, I'm going to type in 4 over 3 as my fraction. And then we have pi. And then our radius is 7, and we're cubing that number. And when we do that, we get 1436.755. But then that's the volume of the entire sphere. So what we need to do with this is we need to divide it by 2 to get the hemisphere. So when we go into our calculator, I'm going to use this really long number that we got, and I'm just going to divide it by 2, and then we have 718.378. And again, that's going to be meters cubed. So now what we have to do is we have the volume of each figure. We need to just add them up. So we're going to take the volume of our cylinder. We're going to add the volume of our hemisphere. And that's going to give us our total volume. So let's go ahead back into our calculator. And notice I don't want to round at all. So what I'm going to do is I'm scrolling up. I'm hitting enter. This was our number for our cylinder. And I'm going to add, and then I'm going to scroll up again. And again, I'm doing this so that I'm not rounding too early. I really want to make sure that my answers do not get messed up. And when we do that, we get 11,801.916. And it said we're rounding to the nearest tenth. So here's going to be 11,801.9 meters cubed. So again, refreshing, we just broke up our shapes, found the volume of each one, and then we added them all together at the end. So the second skill is going to be finding the volume of a quote-unquote shaded region. Now, we did this with two-dimensional composite figures as well, where all that we did was we found the volume of the outer shape first, we subtracted the volume of the inner shape, and then we were able to get our answer. So 99.99% of the time, this is the process that you're going to have to do when you have these shapes within one another. So the difference is, when we go to this slide right here, we can see we're kind of gluing the shapes together to make a really complex composite shape. Whereas in the examples or the questions for skill 2, you can see our shapes are inside of one another. And when your shapes are inside of one another, that's when you're going to be using this concept of let's find the volume of the outer shape first, subtract the volume of the inner shape, and then we'll be good. So here we have a solid wooden post in the shape of a right rectangular prism. So that's going to be our first shape. That's important. We're highlighting that. Measuring 5 by 9 by 24 is drilled with a cylindrical hole with a radius of 2 centimeters. Find the volume of the post after the hole has been drilled. Round your answer to the nearest tenth if necessary. So again, when you have two shapes within one another, we identify them first. So here we have a rectangular prism for shape 1 for our outer shape. Our inner shape is a cylinder. And it tells us that the radius is 2 centimeters. Now that's not given to us in the diagram, so I'm going to go ahead and draw it, that radius is 2 centimeters, because it might help us see some stuff. So for a general prism, we are given the volume formula. So the volume formula for a general prism is the area of the base times the height. Now, for a rectangular prism, the base is a rectangle. So instead of writing V equals capital BH, we know that to find the area of a rectangle, we just do L times W, right? So volume of a rectangular prism, we just write L times W for our area of our base times the height. So we're just multiplying our 3 dimensions. So we get 9 times 5 times 24. And when we go to our calculator, we get 1,080. And that's going to be cubic centimeters. Now our inner shape is our cylinder. And for a cylinder, when we visit our reference sheet, we know already from the previous example that we're given it. So cylinder, the volume is pi r squared h. Now, the radius of our cylinder is given to us. That's going to be 2 squared. And then the height of our cylinder is going to match, like the cylinder is going all the way through this rectangular prism. So the height of the cylinder is going to be this value right here. And we can see it's going to be 24. Now when we plug this into our calculator, pi times 2 squared times 24, that gives us 301.593. And that's cubic centimeters. So to find the volume after the drilling of the hole, we're just going to subtract our numbers. So we're going to take the volume of the rectangular prism, we're going to subtract the volume of the cylinder, and then that's going to be our answer. So again, we don't want to round too early. It's really nice that we have this whole number here. So we're going to do 1080 minus. We're going to scroll up. We're hitting enter on the number that represented our cylindrical volume, and we have 778.4. Again, it's cubic centimeters. Alright, so here's a little refresher on what you need to grasp from the lesson. So we cut up complex composite figures into familiar shapes. We find the volume. So remember, we just add up all of the individual volumes together to find the volume of the entire composite figure. Just be mindful of the words semi, hemi, and quarter, because those tell you, hey, you might not be using the entire volume of the cylinder or the entire volume of the sphere. You might have to divide by 2 or divide by 4. So be very careful when you're doing that. Be organized with your work. Separate it just like we did in the video. And then skill number 2 was when we're finding the area of shaded and unshaded regions, and we do this when the figures look like they're inside of one another, we find the volume of the outer shape, and then we subtract the volume of the inner shape. And we use this method here of adding them up when it seems like our figures are glued together instead of them being inside of one another.